In this video, we'll review temperature. This is one of the physical properties that we can measure in the lab. So temperature is a measure of how hot or how cold an object is. Really, it indicates how heat is flowing. Something that is at a higher temperature will lose heat to something else that's at a lower temperature. We usually measure this with a thermometer, but we also experience this in our day-to-day lives. So if you're holding a hot cup of coffee or tea, the hot liquid is warmer than your hand. So heat flows from the hot coffee or tea to your colder hand right here, the surroundings. That's what we mean by heat flow. The heat will flow from the hot liquid to the hand until both are at the same temperature. So if you hold a hot cup of coffee, eventually it comes to room temperature or body temperature. Now we'll use a thermometer to measure this, as I said, but we're also going to have several different ways of measuring it. In Fahrenheit or Celsius are the ones that we're most used to. And the conversion from Fahrenheit to Celsius follows these equations right here that are just rearrangements of one another. This might be a helpful way to look at this with our temperature units, is looking at the different scales of temperature. So we've got Fahrenheit, Celsius, and then Kelvin. So comparing Fahrenheit and Celsius, we can see that 1 degree is different between the two scales. Or you can see that if water boils at 212 Fahrenheit and 100 degrees Celsius, but freezes at 32 Fahrenheit, and 0 degrees Celsius, the difference between the two is 100 degrees in Celsius and 180 degrees in Fahrenheit. And this is how we get such a complicated way of converting between the two, is because each degree doesn't represent the same change in temperature. And so we won't work in the Fahrenheit units when we talk about temperature. We'll work in Celsius or Kelvin. But since a lot of us think in Fahrenheit, especially when we think about what temperature the oven's at, or do we have a fever, sometimes it's helpful to be able to convert to kind of translate a temperature into a unit you're more familiar with. Now, Celsius is really useful and we'll take a lot of measurements in it. But when we do calculations, we're most likely going to use the Kelvin system. And there's a reason for this. Now, a degree Kelvin and a degree Celsius are the exact same. Like 1 degree change in temperature in either scale will change the same amount of energy. Or, sorry, the temperature will change by the same amount, which is handy. The difference is how 0 is defined. So 0 on the Kelvin scale is defined as absolute 0, where a system has no kinetic energy. And Celsius defines 0 as the point in which water freezes. Now on the Kelvin scale, water freezes at 273 Kelvin. So Kelvin is the same scale except the 0 is redefined. And so you have no negative values in the Kelvin scale. And that is really useful when using temperature in calculations. And that's why we use the Kelvin scale so much. Now, converting between Kelvin and Celsius is pretty easy. Since it's just defining where 0 is, we can convert Celsius to Kelvin by adding 273, or we can convert to Celsius from Kelvin by subtracting 273. And so that makes things a little easy because the change of 1 Kelvin to 1 degree Celsius is the same. We'll add or subtract 273 to convert between the two. And this is why when we are looking at significant figures, we have to rely on our addition and subtraction significant figure rules. Otherwise, we primarily use multiplication and division. Let's do a little example together. If you want, take a moment to pause the video and try it on your own. And I'm now going to walk through the solutions. We have a person with hypothermia that comes into a hospital, I'm sure. They have a body temperature of 34.8 degrees Celsius. What does that mean in Fahrenheit? And what does that mean in Kelvin? So for Fahrenheit, degrees Fahrenheit equals 1.8 times degrees Celsius plus 32. So this will equal 1.8 times my degrees Celsius of 34.8 degrees Celsius plus 32. So my significant figures are going to track with my inexact number, the 34.8. And if I start plugging this into my calculator, I'm going to start with the first step, which gives me a value of 62.64000 plus 32. Now I've got three significant figures, so I'm going to underline the 6. It's 1, 2, 3, the third digit. That'll be what I base my sig figs on. Now I'm going to add 32. So this was the multiplication division sig fig rule. Now I'm going to do the addition subtraction sig fig rule. And so if I add 32 to this number, I'll get 94.64000. Now I'm going to report this to the least number of decimal places, but I'm going to do that only for my inexact number, which has become this one right here. So it has one decimal place. All right. So I'll report one decimal place. So this equals 94.6 degrees Fahrenheit. Now let's look at Kelvin. To calculate Kelvin from degrees Celsius, we can use the equation Kelvin equals degrees Celsius plus 273. So that's going to be equal to my 34.8 degrees Celsius plus 273. Again, my inexact number here is this 64.8, and it has one decimal place. So when I do this calculation and report my significant figures, it'll be based on that 38.4 and that one decimal place, and not the 273, which is an exact number. So I get 307.8000. Got one decimal place, so I'll report this to 307.8 Kelvin. Notice that I've gone to 4 significant figures from a number that is 3 significant figures. That's because I use that addition subtraction sig fig rule, which can ultimately make you feel like you're losing or gaining significant figures, which can be confusing, especially under stressful situations like quizzes and exams.